All right, so lesson 3.1 goes over a really important rule. This is one we use all the time, and it's called the chain rule. So to kind of introduce that, we're going to do this little discovery example. It says use the product rule to find the difference. All right, so I want to take the derivative of x cubed minus 3, x cubed minus 3 squared. So we know that's the same thing as x cubed minus 3 times x cubed minus 3. So we're going to use the product rule, right? So we take the first, which is x cubed minus 3, times by the derivative of the second. So the derivative of x cubed minus 3 is 3x squared, plus, now take the second, which is also x cubed minus 3, times the derivative of the first, which is, again, 3x squared. We can add those together, so they're like terms. If I add them together, that'd be 6. Now what we're looking for is there a shortcut way to get from here down to here? Something that might help is you could think of this 6x cubed as being 2 times 3x squared times x cubed minus 3. So take just a second, if you need to, pause the video. See if you can come up with a connection between that original problem and that final, the final way I wrote that answer down below. All right, so hopefully you noticed, right? Remember our power rule, right? You take the 2 and drop it down in front. That's where that 2 comes from. And notice how that's just to the first power. But we also have this 3x squared. The 3x squared is the derivative of the inside of the function. So what it turns out, this is the way the chain rule works, is you can use all those derivative rules we've already learned. In this case, it's the power rule. You can apply the power rule, which again, take the 2, drop it down in front, subtract 1 from the power. But then we have to multiply by the derivative of the inside. In that case, the derivative of x cubed minus 3 is 3x squared. And that can help us find the derivative, which is a lot quicker and easier usually than, for example, multiplying all this out and using the power rule. So that's what the chain rule is. That's what we're doing today, right? I know one can use the chain rule. So if you look up here, the chain rule applies if you have what we call a composition of functions. And we talked about this back in Unit 0. It's been a while. But the composition of functions is when you have one function embedded or inside of another function, right? F of g of f of x. And the way you do it is you take the derivative of the outside. The outside is f of x, so I have f prime of, and the inside stays the same. It's still g of x. But then you have to multiply it by the derivative of the inside. This is another way to think about it. If I have the derivative of f of u, and u is a function of x, I take the derivative of the outside, f prime of u. Notice how the inside stays the same. And then you multiply it by the derivative of the inside. Let me show you some examples how this works. So look at number 1, right? If the way we did this before is we had to multiply that out. We had to take 3x cubed minus 5x and times it by itself 4 times, which this would be a long, kind of painful process if we really had to do that. But instead, we're going to use a chain rule. Okay, so what we look for is what's the inside function and what's the outside function. So the inside function is 3x cubed minus 5x. The outside function is the 4th power. So I'm going to do the outside function. I take the derivative of the outside, 4. The inside stays the same, 3x cubed minus 5x. And I subtract 1 from the power. Now this is the part you have to remember. That's the first step. And then I have to multiply it by the derivative of the inside. So the derivative of the inside would be, drop the 3 down. 3 times 3 is 9. X squared minus, and derivative of 5x is 5. Okay, there's my derivative right there. So this first part, right, that was taking the derivative of the outside, the 4th power, times by the derivative of the inside. Okay, number 2. So if you look at this one, the outside function is the sine. The inside function is the 3x. So that we take the derivative of the outside. That would be the cosine. The inside stays the same. Then we have to multiply it by the derivative of the inside. Well, the derivative of 3x is 3. There's my derivative right there. 3 is a little bit tricky. Write it this way. We've talked about this, but if you write it as being the square root of a cube is the same thing as saying to the 3/2 power. Okay, now my outside function is the 3/2 power. My inside function is the 2x squared minus x. So take the derivative of the outside. So the 3/2 drops down. 3/2 2x squared minus x, subtract 1 from the power, times by, now we have to times that by the derivative of the inside. So that's the 2x squared minus x. So that would be 4x minus 1. And I'm done. Number 4, be careful with this one. I'm going to rewrite it again. 3 cosine squared of theta is really the same thing as saying 3 times the cosine of theta squared. So we've got that 3 on the outside, but remember the 3 is really just a scalar multiple. So we don't have to worry about it. It's just going to stay the same. So h prime of theta is going to equal 3 times. Now take the derivative of this. So the outside would be the square. The inside would be the cosine of theta. So the 2 is going to drop down. 2 cosine of theta to the first power. I got to subtract 1 from that power. Times by the derivative of the inside, which derivative of the cosine is negative sine of theta. So if we just clean that up a little bit, it'd be negative 6 cosine of theta sine of theta. All right, 5. So this is one we could do with the quotient rule, but this is another way we could do it. Is if I rewrite it this way, g of x equals 2x plus 1 to the negative 1. So I move the 2x plus 1 up to the top and make it to the negative 1. Now I can actually just use the chain rule. So the outside is a negative 1 power, the inside is a 2x plus 1. So g prime of x is going to equal, drop the negative 1 down, subtract 1, and then times it by the derivative of the inside. So derivative of 2x plus 1 just be 2. So we could simplify that. That would be negative 1 times 2 would be negative 2. I can move the 2x plus 1 back down to the bottom, make it a positive 2. And that's the same thing you get if you use the chain rule. Or sorry, if you use the quotient rule. We just did the chain rule. What we have to be careful with, if you look at number 6, let me give myself some more space here because we're going to need some more space for that problem. But if you look at number 6, you have to use the product rule here. So make sure you recognize that. This is 3x squared times by the cube root of 9 minus 4x squared. So we have to use the product rule. But when we go to use the product rule, on this part right here, when we take the derivative of that, we've also got to use the chain rule. So this is going to get to be a long problem. So I'm going to write it like this. I'm going to go f of x is equal to 3x squared times by 9 minus 4x squared to the 1/2. Okay, so I'm going to do the product rule. F prime of x equals the first 3x squared times by the derivative of the second. When I go to take the derivative of that, I'm going to have to do the chain rule. I've got the 1/2 on the outside, it's the outside function, and 9 minus 4x squared on the inside. So the 1/2 drops down, 1/2 times 9 minus 4x squared to the negative 1/2 times by the derivative of the inside, which is a negative 8x. Okay, that's all. That whole thing right there, that's all just the derivative of my second function. I'm going to need, I didn't even give myself enough room there. Let me erase this over here and we'll slide this over because we still have to do the second half of the product rule. Slide this over here. Okay. Okay, now I'm going to go plus, and now I take the second, which is that. So 9 minus 4x squared to the positive 1/2 times the derivative of the first one. Derivative of 3x squared is 6x. Not a whole lot we can do here. We can do a little bit of cleaning up, though. I've got, let's see, 3 times 1/2 times a negative 8. So I'm going to go 1/2 times negative 8 is negative 4 times 3 is a negative 12. 3 times the x squared and the x together also. And I'm going to move that 9 minus 4x squared down to the bottom and make it a square root. Okay, I'm going to rewrite that one as being just 6x square root of 9 minus 4x squared. So I just, multiplied my negative 8 and a half as negative 4 times 3. Just multiplied all those together, got negative 12. I have x squared times x. And then I just took this part, moved it to the bottom, and made it just square root. Okay, so that's a combination, right? We can use all those same derivative rules we've always used. We can use those in combination with the chain rule. But the chain rule, again, what we're focusing on is it's when you have something like this, where you've got an outside function, the 1/2 power is the outside, and an inside function, right? It's the composition of functions is when we use the chain rule. Let's try this one. F of t equals sine cubed of 4t squared. So again, just be careful with these. Always rewrite those if it's a sine, if it's a trig function, rewrite it as being, right, the sine to the 3rd power. Now this one's tricky. We've actually got to do the chain rule 3 times, and I'll show you what I mean is we have the cube's an outside function, and inside the cube we have the sine, and inside the sine we have the 4t squared. So it's like multiple layers, which is fine. We just apply the chain rule each time. So start with the outside function first. Start with the 3. So we're going to go f prime of t. I drop the 3 down, 3 times, and the inside stays the same, sine of 4t squared, now to the 2nd power. Multiplied by, and now do the derivative of the inside. So the derivative of sine of 4t squared would be the cosine of 4t squared times by, when I take the derivative of the sine of 4t squared, the outside is a sine, it changes to cosine, but I have to times it by the derivative of the inside of that, which is 8t. And we're done. So notice, this was the derivative of the cube on the outside. This was the derivative of the sine, and this was the derivative of the inside of the sine, which is the derivative of the 4t squared. So you can have these chain rule where you have to apply it multiple times if there's multiple layers. One thing you have to be really careful with, and you'll see it in this next example, is making sure we're careful in telling the difference between the product rule and the chain rule. So if you look at A and B, one is the product rule and one is the chain rule. So if you look at A, we want to find the derivative of, we want to find f prime of 2. So I got to find f prime of x. Okay, in this case, those two are multiplied together. So we've got to do the product rule. So I take the first, p of x, times the derivative of the second, q prime of x, plus the second, q of x, times the derivative of the first. And then it wants me to find f prime of 2. So I'm going to plug 2 in everywhere. So p of 2 times q prime of 2 plus q of 2 times p prime of 2. Okay, let's figure all these out. So p of 2, so right here it says I'm plugging 2 in. So when I plug 2 in to p of x, I get 5 out. When I plug 2 into q prime of x, I get 6 out. Q of 2, I get 3. And p prime of 2, I get 7. And I'd work that out to find my answer the rest of the way. Okay, compare that to this one. So that one was a product rule because the two functions are multiplied together. This one is, this is the composition, right? It's p of q of x. So q of x is inside of p. So make sure we're careful and don't get these two confused. That's a really common error. So on this one, right, if I want to find h prime of x, I take the derivative of the outside, make sure the inside stays the same. But then I multiply it by the derivative of the inside. That is my derivative right there. Now it wants me to find h prime of 2. So plug 2 in there. So you got to be careful. This is going to be p prime of q of 2 times by q prime of 2. So let's figure this out. I start with that. Q of 2 is 3. So I have p prime of 3 and q prime of 2. It's right there. It's 6. But I still have to figure out, I have to take that 3 and plug it into p prime still. So if I come down here, I got to plug 3 into p prime over here. That would be 8. So 48 is our final answer right there. So again, just make sure you're differentiating. Don't do the chain rule if they're multiplied. That's the product rule. And then just be careful not to do the product rule here, but we have to do the chain rule on that one. Okay, that should take you to the assignment. And again, if you look at these first 12 problems, these are all just going to be practicing the chain rule. Well, let me take that back. Some of these may be easier to do other ways. Like this one right here, I think I would just do quotient rule. But the majority of them are going to be chain rule as you work down through there. So make sure you try some of those problems. If you run into questions as you go, make sure you let me know, and I can help you with them. Thanks, guys.